Target 7.6 asks you to determine the limiting reactant when given moles of two reactants. So a limiting reactant problem is going to be a little bit different because you're given two reactants and asked to find how much product you could form. To solve these, you have to find out which reactant runs out first. In the reaction A plus B yields C plus D, if there is more reactant A than is required to react with all of B, then what can you say? Well, we can say that if there's more of A, then B runs out first, which means that B is my limiting reactant. What is needed to determine a limiting reactant? Well, you need to know the available amount of each reactant. So when you read a limiting reactant problem, you actually have two givens. If 15 moles of iron sulfate and 28 moles of potassium hydroxide react, what will be the limiting reactant? So my strategy for these is to turn your moles of the given into moles of a product, and it doesn't matter what product you choose as long as you're consistent. So I'm going to take my given, which is 15 moles of iron sulfate, and I'm just going to turn that into K2SO4. So 1 iron sulfate will produce 3 moles of K2SO4. Then I'm going to do a second problem with the second given. So 28 moles of KOH, and we're going to turn the KOH into the same product, the K2SO4. So there are 6 KOH for every 3 K2SO4. Go ahead and solve. 15 times 3 divided by 1 is 45. 28 times 3 divided by 6 is 14. So what this says is 15 moles of iron sulfate will produce 45 moles of potassium sulfate. 28 moles of potassium hydroxide will produce 14 moles of potassium sulfate. So of these two reactants, the potassium hydroxide is going to run out first. So if I'm asking you to identify the limiting reactant, we say that the KOH, that's my limiting. If the question asked how much product could be produced, well, then your answer would be 14. It's not the 45. We don't have enough to create 45 moles of potassium sulfate. We only have enough ingredients to make the 14 moles. Problem 2 says if I have 13.4 moles of aluminum and 14.4 moles of HCl, how many moles of K2SO4 could form? Okay, I have a feeling that this is a typo. Let's say moles of aluminum chloride. So starting with 13.4 moles of aluminum, I'm going to turn that into moles of aluminum chloride. There are 2 aluminum for every 2 aluminum chloride. 13.4 times 2 divided by 2 is 13.4. And then I have to do a second problem with my second given. 14.4 moles of HCl. There are 6 HCl for every 2 aluminum chloride. So 14.4 times 2 divided by 6 gets me 4.8 moles of aluminum chloride. So here's what I've solved. 13.4 moles of aluminum would make 13.4 moles of aluminum chloride. 14.4 moles of HCl would make 4.8 moles of AlCl3. You want to compare your two numbers, your two answers, and the answer that's the smallest number is really the most that you could make. I don't have enough to make 13.4 moles. I only have enough to make the 4.8. So when the question says, what is my limiting reactant? It's what reactant, what given ran out first. In this case, the HCl ran out first. So HCl is my limiting reactant. I have extra aluminum, so I would say aluminum is my excess reactant because there's left over.